Hi everybody, Mrs. Pesic here,
And Miss Bella here.
and we are looking at section 10.5, the law of sines. The objectives are to determine the area of a triangle given side, angle, side information, and to use the law of sines to find the side lengths and angle measures of a triangle. Let's start with this example. We've got a sail maker who is designing a sail that will have the dimensions shown in the diagram. Based on these dimensions, the sailmaker can determine the amount of fabric needed. So the area of a triangle, as you know, is 1/2 the base times the height. In this case, it's going to be 1/2 times 2.13 times whatever the height is. But we're not given the height, but we are given that this angle is 73 degrees and that this side here is 2.96 meters. So what we can do is look at just this triangle right here and use SOHCAHTOA to figure out the height. So with this triangle, we know that we have this angle here is 73 degrees, this is 2.96, and we're trying to find h. So using sine is the opposite over the hypotenuse, so the sine of 73 degrees is going to equal h over 2.96. So if we wanted to, we could solve for h and do 2.96 times the sine of 73 degrees. What they're showing here is that you can just, in general, take h over c as your sine of a, and then if you multiply both sides by c, you get h equals c times the sine of a. So bottom line, plug in that c times the sine of a, wherever you see an h. I see an h right there. So I have a formula for finding the area of this sail. It's going to be 1/2 b, which is this length, times c, which is this length, times the sine of this angle. This formula allows you to determine the area of a triangle if you know the lengths of two of its sides and the measure of the angle between them.
Now, when we're doing this, a helpful hint here is that the angle and the side opposite that angle are labeled with the same letter. The capital letter will be used to name the angle, and the lowercase letter will be used for the side. So this box here to talk about the area of the triangle kind of demonstrates that again. So notice that our triangle in this case, right here, triangle ABC, you notice that the angle A across from it is side A with a lowercase letter. Again, angle B across from that is lowercase b, the side length, and across from C is lowercase c. So we have three different ways, again, depending on what situation you are given, on how to find the area of a triangle. All of them have the same idea, that the area will be 1/2, again, I'm looking at the first one here, 1/2 b times c times sine of a. So again, notice in that case, when I say side length b, so that would be here, times side length c, which would be here, well then I must be using the sine of the angle in between them, so sine of a. Compared to if I look at the second formula, it's the same idea, but I'm using A and C. So if I take side A and side C, well then I must use angle B. And kind of the same idea there, again for your last one, A times B, well A and B, so what angle must you use? You must use angle C. So every letter is kind of a way to think about that. Every letter will be used in here once somehow. So let's actually find the area of our first triangle right here. So I want to find the area of the triangle. In this case, notice what we have. Again, it might be helpful that you have a side length and a side length, and you have the angle in between them, which means that this is a candidate for using the area formula involving the sine. Again, if it helps you, if you want to label like, okay, A, B, C, well then that means that, over here, this is lowercase a, this is lowercase b, and then this is angle C. So the formula I'm going to use for the area, again, will be 1/2 A times b times sine of angle C. So the two sides multiplied by the sine of the angle in between them. So side length A is going to equal 3 meters. Side length B is equal to 5 meters. So I'll bring down my 1/2 times 3 times 5 multiplied by the sine of my angle, so the sine of 40 degrees. Again, I'm going to go to my calculator, multiply that in. So on Scratchpad or a calculator page, we'll take 1/2 or 0.5 times multiplied by 3 times 5, multiply by the sine, hit that trig key again, sine of 40. Make sure your calculator knows you're working in degrees, so put a degree symbol. And we're going to say that is equal to, what were we rounding to in this one? Nearest tenth, I think. So 4.8. Yep. So our area, we're going to say 4.8. Again, I want to put units on it since my measurements were in meters and I'm talking about area that's always squared. So my area is 4.8 meters squared. Here's your first must do, doing the same idea. Find the area of this triangle given that we have a side of 8 feet, one side of 12 feet, and the angle in between them is 86 degrees.
Okay, so that brings up the law of sines. The law of sines is a way of finding missing pieces of a triangle, missing side lengths or missing angle measures. So the law of sines is the sine of angle A divided by the side length A is going to be equal to the sine of angle B divided by, the sine of angle B divided by the side length B, and then the sine of angle C divided by side length C. The law of sines allows you to solve a triangle as long as you know either of the following. So if you know two angle measures and any side length, that would be an AS arrangement or an ASA arrangement, then the law of sines will work. Or if you have two side lengths and the measure of an angle that is not between them. So that would be an SSA arrangement. So if that's the situation you have, then you can use law of sines to find out the missing pieces of your triangle. Let's take a look at this example. So here we are finding the missing pieces. When they say solve the triangle, that means find the missing pieces here. So we need to find the measure of angle E. All right. I'll just use capital E. So that's our measure of angle E. And then we want to find the missing side lengths of side D, and we need to find missing side length E. So let's start with finding the missing angle first. We are trying to find this angle. If you remember from geometry, the three angles of a triangle have to add up to 180. So we can actually do 180 minus 33 minus 28, and that is going to give us 180 minus so 28 minus 33. All right, 119. So we get 119 as the measure of angle E, 119 degrees. Now that we have that, now we can use law of sines. We can say sine of angle E over the length of side E is equal to the sine of angle D, for example, over side D. And if we plug in what we know, we will have, we know angle E is 119, so we can say sine of 119 degrees over E, which is a side we don't know. Oh, I guess I better start with angle F. My bad. So let's go with sine of angle F over 15, because I actually know the opposite side. So sine of angle F over side F. So that's going to be sine of 28 degrees over 15. All right, so to solve this, we are going to cross multiply. So if I cross multiply here, I get E times the sine of 28 degrees equals 15 times the sine of 119 degrees. And if I divide both sides by the sine of 28 degrees, then we should get our answer, because those are dividing out. So we're looking for, to put into our calculator, 15 times the sine of 119 degrees over the sine of 28 degrees. So let's see what that's going to be. So we want 15 times the sine of 119, don't forget the degree symbol, and then divided by the sine of 28 degrees. Yep. All right, and our answer is going to be 27.9 approximately for side E, 27.9. And then we would do the same thing to find, so 27.9 is E, and now we will set this up one more time, law of sines. We can say again, sine of angle F over side F equals sine of angle D over side D, because that's the one we haven't found yet, right? And so we're going to say sine of 28 degrees over 15 equals sine of 33 degrees, that's angle D, over our missing side D. So if we take that, oh boy, that's not what I wanted to do. Okay, so now that we have that in place, we are going to finish this up by cross multiplying here. So we're going to have D times the sine of 28 degrees equals 15 times the sine of 33 degrees. Divide both sides by sine of 28 degrees so we can get D by itself. And that means what we are looking for to find D is 15 times the sine of 33 degrees over the sine of 28 degrees. And when you do this on your calculator, you might want to do up click a couple times and pop that down, and then you can just adjust what you have there. So we wanted 15 over sine of 33 degrees over sine of 28. Turns out to be 17.4. So D is equal to 17.4, and that was our last piece that we needed here. All right.
So that brings you to your second must do. You need to solve this triangle. Again, round everything to the nearest tenth. See if I can make that a little, there we go. Okay, so again, you're going to be looking for three pieces here to solve it. You need to know what is the measure of angle K. Use what you know that they all add up to 180 to find that. You're going to find out what is the length of H, so that side length, and what is the length of side K. Remember, you're going to use the law of sine. So we have letters, what, H, J, and K. So sine of H over H equals sine of J over the side length J equals sine of angle K over side length lowercase k. Again, take whatever two you need to help you solve the pieces that are missing. Start off by using the fact that you know about J here. So you'll use that for both of them. All right. Next up now, so we talked about, I'm just going to go back for 1 second. We talked about when you use law of sine right here that there were two options. So you had angle, angle, side, or angle, side, angle. We also talked about using side, side angle when that angle was not in between. And that's going to kind of relate to this part right here. So we have side, side angle when we use the law of sines in this case. So again, if I had some triangle, and in the triangle I might have known that this was 5 and this was 7, but I know the angle measure over here. Okay. In that case, it is possible that we could have 0, 1, or 2 triangles that actually would be possible. So this is called the ambiguous case because sometimes it would work, sometimes it wouldn't, sometimes you get more than one answer. So in Algebra 2, we are only going to look at the side-side angle case when one triangle is possible. So we'll only give you ones where one is going to happen here. There will not be 2 choices, or it just won't work at all. And we'll look at how that would come up. In trig next year, you will be given a side-side angle case where 2 triangles might be possible, and you'll talk about how to do that. You'll learn how to determine if you can have 2 triangles, and you'll be able to find both of those next year. But right now, it's either 1 or none. Okay, that's what we're looking at. So here's our example. In this one, in the side-side angle example, there's only 1 triangle possible. So I'm telling you it works. You're going to find 1. You need to solve it. So I'm going to start off. I'm given lowercase a, which means that's a side, 10 meters. Lowercase b of 4 meters, again another side, and the measure of angle A, so 120 degrees. So I'm going to start off, again, just kind of just doing a rough sketch, just a triangle. I'm going to label this A, B, and C, and labeling A, B, and C in this case, capital A, B, and C is our angle measures. Lowercase a, b, and c will be our side length. So what do we know so far? We know that lowercase a is 10 meters. Lowercase b is 4 meters, and the measure of angle A is 120 degrees. So hopefully, again, you can see, based on what we were given, side here and a side here, my angle is not included. So this is that ambiguous case. So how am I going to solve this triangle? Well, I can't find an angle first, so we're going to have to find a side first, but let's list what we're going to find overall. I'm going to need the measure of angle B, so capital B, the measure of angle C, And I also need side length C in this case as well. So those 3 items. Now in order to use the law of sines, you have to have 3 out of 4 pieces of what I'm looking for. So again, my option here, I have copy this over one last time so we can see kind of what information do we have to help us. So we can use any 2 out of 3 of these to help us set up. In this case, I know information both about angle A and side length A. So I know I'm going to use this one to start with. What else do we know to start? We know little b. So the first thing we must be solving is what angle, capital B, is equal to, what that value is. So here's how we're going to start this off with. We're going to say that sine of capital A, so sine of angle A, so sine of 120 degrees is equal to lowercase a, or over lowercase a, excuse me, side length A, 10, equals, again, I'm going to use this one right with it because I know some stuff about side length B. So this is equal to sine B divided by what your value of B is, which is 4. Now, in order to solve for this angle, I'm going to cross multiply as my first step. So if I cross multiply these, I'm going to have 10 times the sine of B. And this will equal my other direction, which is 4 multiplied by the sine of 120 degrees. Again, my goal is to get B alone, so I'm going to first get rid of the 10 over here, divide by 10 over on this side. Again, be careful, do not divide that 10 into the 120. That is part of the angle measure for sine. So right now I have that the sine of angle B is equal to, I'm just going to leave it just like this, I'm not even going to simplify right now, 4 times the sine of 120 degrees, all divided by 10. In order to do this, we talked about what this is really asking. It's really saying what angle measure is going to give us a sine that it's equal to this. So I need to rewrite this using the inverse trig function. So angle B is actually equal to sine inverse of 4 times the sine of 120 degrees, all divided by 10. So that's my first step there to go ahead and find out what that is. So on my calculator, again, in that trig key, you'll find sine inverse. We have a fraction we're going to put in here. We have 4 multiplied by the sine, and our angle was 120 degrees. Again, make sure you put in that degree symbol when you're writing that. And then divided by 10. Again, parentheses are very important here. Make sure the sign is of this entire function. So we will find out in this case that our value in this case is 0.35. Now that doesn't really seem to make sense for an angle in this case, but that's because our calculator is in radian mode. So I have to convert that to degrees. So I'm going to multiply my answer by 180 divided by pi. So convert it over to an answer that would match what we're working with. So our angle, we'll round it to 20.3 for our angle measure in this case. So we have found that B is equal to about 20.3 degrees. So if I slide back up here for a second, what do we know? We know that angle B is 20.3 degrees. So again, that is this angle right here. I still have 2 unknowns in this case. Well, since I know 2 out of 3 angles in the triangle, I can add those up and subtract. So to find angle C, this is really 180 minus 120 minus 20.3. Again, all of those are in degrees, of course, knowing what I know about a right triangle. So 180 minus 120 minus 20.3. So angle C has a measure of 39.7 degrees. All right, last up now, I need to find the side length of C. So again, based on our original information, we already knew, well, that's going to stay there, so we'll just, all right, we're just going to move this. Well, we don't need that information anymore. Okay, we already knew about sine A. We were given the 120 and given the 10, so I still want to use this one to help me solve. I am now looking for information about C, so I'm going to use this setup here. So I'm really going to be using the fact that sine of A over lowercase a is equal to sine of angle C over side length C. Plugging in the values I know, I'll say sine of angle A, so sine of 120 degrees, divided by side length A, which is 10, will equal the sine of angle C. We just found that 37.9 degrees, 39.7, said it backwards, wrote it right, divided by lowercase c. So how am I going to solve this? Well, I'm going to cross multiply. So these 2 values, so C times the sine of 120 degrees is equal to these 2 values, 10 times the sine of 39.7 degrees, and to solve for C, I'm going to divide both sides by the sine of 120 degrees. So sine of 120 degrees. So again, in my calculator, I know I'm running out of room a little bit. You're going to type in c is equal to 10 multiplied by the sine of 39.7 degrees, all divided by sine of 120 degrees. All right, so we are going to, that was our format we used before, so might as well use that to help us out a little bit here. So we knew that we had, I believe it is 10. Yes, we might need to double check that. Okay, 10. And then we had sine of 39.7. Again, remember, use that copy and paste feature to help you out. And then we're dividing by the sine of 120 degrees in the denominator. So if we find out what that's approximately equal to, we find out, again, rounding to the 10th place, 7.4 would be the length of side C. So we have 7.4, and again, if I go back up, I believe, what are our units on this? Meters? Meters. Okay, so we've solved it and found all of the missing pieces of this triangle.
Okay, so let's look at this example. In this SSA example, show why no triangle is possible. So if we were trying to make this triangle, we have side A is 5 centimeters, side B is 12 centimeters, and the measure of angle A is 105. So if this is the case, I'm going to try and draw angle A here that measures like 105 degrees. And I'm going to try and have the side B here. Let's say that this angle over here is going to be angle B. So this side over here is going to be B. B is going to be 12. But then side A, which is this little side right here, is only going to be 5. Might not even work to make a triangle, but we're not going to just draw a sketch to find out. Let's actually try using law of sines. Sine of angle A over side A equals sine of angle B over side B. And we're not even going to worry about angle C or side C yet. Let's just see what happens when we try this out. So if we try sine of 105 degrees over 5, and we set that equal to the sine of angle B over 12, and we cross multiply, and we get 12 times the sine of 105 degrees equaling 5 times the sine of angle B. Again, we're cross multiplying. All right, and when we do that and we divide both sides by 5, we get that the sine of angle B is going to be equal to 12 times the sine of 105 degrees over 5. So let's see what happens when we type that into the calculator. 12 times the sine of 105 degrees divided by 5. So we're getting 2.3 for the sine of angle B. So let's write that down. Sine of angle B is equal to approximately 2.3. That means we are looking for an angle B who has a sine of 2.3. In other words, B is equal to the sine inverse of 2.3 radians. So if we try this with our calculator, sine inverse of 2.3, we are getting an error message, non-real calculation. So that's no good. So why does that happen? Well, when we, what you're going to be learning in trigonometry next year, and we can at least introduce you to this idea now, is that the sine of any angle, sine of angle B, sine of angle C, whatever it is going to have to be between -1 and +1. So that's what you're going to learn. And 2.3 is not between -1 and +1. It's greater than 1. So that's why we get an error message, and that means no triangle is possible. All right, so this is an example of the ambiguous case where no triangle was possible. All right, that brings up your third notes must do. You're going to solve the triangle C equals 5, B equals 12, and the measure of angle B is equal to 98 degrees. There should be one triangle possible for this example. All right, and that's it for this video. I hope you took good notes and did all your notes must do.
Thanks for watching.
See you next time.